let's take a look at the various ways that covalent bonds could be represented. The first is cross and dot. At the A level for cross and dot, the two bonding atoms will have regardless whether they are the same element, would be represented by cross and dot. So in this case, these nitrogens could have its electrons represented in crosses. So there are 5 valence electrons in this nitrogen. While in the other nitrogen, the valence electron is represented by a dot. Next, we take a look at the displayed formula. No difference from O level. Key things to remember is that if it's a double bond, you have to represent it with 2-stroke. Lewis structure is actually an extension of the displayed formula, but all other non-bonding electrons are being depicted with dots. Finally, we come to the shape of molecule. When you look at the shape of molecule, the normal line that's drawn represents the fact that all the bonds sit on the same plane. When you actually have a dash, the dash represents that the fluorine atom now pops up of the paper, while the dots actually depicts that the fluorine atom pops behind the paper. Finally, let's take a look at some of the rules that's been applied when you actually do your cross and dot. Rule number 1 is that the atom with the least electronegativity becomes the central atom. So in the case of carbon dioxide, C is the least electronegative, therefore it is more generous, it's sharing its electrons with the other atoms. The atoms which are more electronegative will always be non-central atoms because they just want to share with one atom, specifically the central atom. In rule number 2, atom that's capable of expanded octet electronic configuration also tends to be the central atom, so that they can actually share with more bonding atoms, as they are able to accommodate beyond 8 electrons. Finally, if you have any molecule that involves hydrogen, hydrogen, despite its low electronegativity, cannot be the central atom because it can only share with one atom. So in the example of NH3, you will find that hydrogen, though is the least electronegative atom, it is not the central atom, while nitrogen, being the more electronegative atom, becomes the central atom. Finally, we take a look at the cross and dot for cation and anion. In the case of cation, the atom that is the least electronegative would loses the electrons to produce the cation. In the case of NH4+, you'll find that this hydrogen actually loses its electron, and in this context, nitrogen donated both its electrons to actually the H+ to form the covalent bond. The next example we look at is PCl4+. In the case of PCl4+, you will find that again, phosphorus, which is the least electronegative atom, loses one of its electrons. So phosphorus, which is group 15, should have 5 valence electrons, but as depicted in the diagram, it only has 4 because it loses one of its electrons. In the case of the anion, the most electronegative atom is the one that gains the electron. For example, in the case of NH2-, in NH2-, nitrogen, being the most electronegative atom, gains the foreign electron. Next example we look at is PCl6-. In PCl6-, again, Cl- gains the foreign electron, and thereafter it shares a pair of its electron with phosphorus.